In order to quantify our data, we use the Shannon-Weiner and Simpson diversity indices. These indices provide researchers a mathematical measure of species diversity in a community. The Shannon-Weiner index is what we call an information statistic index. This means it assumes that all species are represented in a sample and that they are randomly sampled from each other. The Simpson's index is what we call a dominance index. This is because it gives more weight to common or more dominant species. In this case, a few rare species with only a few representatives will not affect the overall diversity of a community. By comparing the developed sites to the undeveloped sites, the developed sites had a higher biodiversity level based on the Shannon-Weiner and Simpson's diversity index. We use the Wilcox rank sum test to calculate the difference between undeveloped and developed sites in order to establish if they are statistically different from one another. As seen in the table, for the Simpson's index, we calculated the p-value to be p equals 0.54, which is greater than 0.05. Since the p-value is more than 0.05, we had to accept the null hypothesis and conclude that the median Simpson indices for the developed and undeveloped sites are not statistically different. For the Shannon index, we calculate p to equal 0.054, which is once again greater than 0.05. Since the p-value is more than 0.05, we had to accept the null hypothesis and concluded that the median Shannon indices for the developed and undeveloped sites are once again not statistically different. Overall, the results gave us that we had to accept the null hypothesis, meaning that there was no difference between the biodiversity levels of the undeveloped and developed sites. This illuminates two factors: the overall importance of having multiple tests for a data set, and then also raising the question if biodiversity is the best measurement to quantify an ecosystem's overall health.